Hello students, welcome to a series of mathematics program for grades 10 and 11. The topic for today is sequences. This is the second lesson on sequences. You will remember that in the first lesson, we had talked about sequences of triangular numbers, for example, 1, 3, 6, 10, and so on. We had also discussed about sequences of prime numbers, sequences of square numbers, of cube numbers. We have also learned about arithmetic sequences where we need to add the same value to get the next term. And finally, the geometric sequences where we have the same ratio between any two consecutive terms. In today's lesson, you will learn how to continue a given number sequence, such as the Fibonacci sequence and the sequence of ordered pairs. You will also learn how to recognize patterns in sequences and relationships between different sequences. And finally, how to generalize sequences as simple algebraic statements. These are some examples of the Fibonacci sequence in real life. Consider the following sequence: 1, 1, 2, 3, 5. What do you observe from this sequence? One, 1. 1 plus 1 will give me 2, and this is the next term in the sequence. Now, 1 plus 2 will give me 3, which is the next term. Similarly, 2 plus 3 will give me 5. So each number is obtained by adding the two numbers which immediately precede it. In fact, 1, 1, 2, 3, 5, 8, and so on is called the Fibonacci sequence. So these are examples of the Fibonacci sequence in real life. You can see the spiral. A Fibonacci sequence is therefore a sequence of numbers in which each successive term is obtained by adding the two previous terms in the sequence. Let us have a look at the first example. Part A, we have 1, 4, 5, 9. So, to get the next term, we need to add the two previous terms. Here it will be 5 plus 9, which is 14. Now to get the next term, it will be 9 plus 14, which is 23. And finally, here we will have 14 plus 23, which is 37. Part B, we have 0, 5, 5, 10. So here to get the next term, it will be 5 plus 10, which is 15. The next one will be 10 plus 15, which is 25. And here we will have 15 plus 25, which is 40. But see now, 1 decimal 2, 2 decimal 0, 3 decimal 2. So again, I need to add the 2 previous terms to get the next one. So it will be 2 decimal 0 plus 3 decimal 2, that is 5 decimal 2. The next term will be 3 decimal 2 plus 5 decimal 2, which is 8 decimal 4. And finally, 5 decimal 2 plus 8 decimal 4, which is 13 decimal 6. For D, I have 3, 3.5, 6.5. So again, I will have to add the 2 previous terms, which will be 3.5 plus 6.5, which is equal to 10. Then 6.5 plus 10, which is equal to 16.5. And finally, 10 plus 16.5, which is equal to 26.5. Next example, find the first 6 terms in a given Fibonacci sequence if the second and third terms are 7 and 12 respectively. So here we have been given the 7 and 12 as second and third terms respectively. And I need to find the first 6 terms. So here, which number when added to 7 will give me 12? How do I get this equation? Remember, to get 12, I need to add the 2 previous terms. So which number added to 7 is equal to 12? 5. Now I need to find the next term. So here it will be 7 plus 12, which is 19. Next term, 12 plus 19, which is 31. And finally, 19 plus 31, which is 50. So I had to find the first 6 terms, which are 5, 7, 12, 19, 31, and 50. So you have a few questions now to practice on the Fibonacci sequence. First question, find the next 2 terms in each of the Fibonacci sequences. And then you have a few more questions to practice. Now we move on to sequences of ordered pairs. An ordered pair is always written in the form x, y, just as in coordinates. So consider the following sequence: 1, 4, 4, 6, 9, 8, 16, 10. What do you observe in this sequence? So we have 1, 4, 4, 6, 9, 8, and 16, 10. If we consider the first term in each ordered pair, the first term, we will have 1, 4, 9, 16. Do you remember what type of sequence this is? Yes, these numbers come from the set of square numbers. So the next 2 terms will be 25 and 36. Now we consider the second term in each ordered pair. So we will have 4, 6, 8, 10, and so on. And here we have a set of even numbers. Or we can also say that we add 2 to get the next term. So the next 2 terms will be 12 and 14. So to complete the given sequence, we will have 25 and 12 and 36 and 14. So 1, 4, 9, 16, 1, 4, 9, 16, we will have 25, 36. But the second term in each ordered pair, 4, 6, 8, 10. So we will have 12 and 14. So for a sequence of ordered pairs, we always consider it as two separate sequences of numbers. We consider the first set of numbers as the x values and the second set of numbers as the y values. We have an example here. Find the next two terms in the following sequences of ordered pairs. Part A, 0, 4, 1, 6, 2, 8. So the first term in each ordered pair will be 0, 1, 2. So the next two terms will be 3 and 4. Now, if we consider the second term of the sequence of ordered pairs, we will have 4, 6, 8. So here, we will have a sequence of multiples of 2, or we can also add 2 to get the next term. So the next two terms will be 10 and 12. So finally, we will have 0, 4, 1, 6, 2, 8. The next two terms will be 3, 10 and 4, 12. Part B. -1, 3, -2, 7, -3, 11. So the first term in each pair will be -1, -2, -3. The next two terms will be -4 and -5. If we consider the second terms, we will have 3, 7, 11. And you can see that we are adding 4 to get the next term. So we will have the next two terms as 15 and 19. 11 plus 4, 15. 15 plus 4, 19. So these will be the next two terms. Now part C. -2, 1.3. -5, 1.5. -8, 1.7. So the first term in each pair, we will have -2, -5, -8. So we are subtracting 3 to get the next term. Therefore, the next two terms will be -11 and -14. Now, if we consider the second term of the sequence of ordered pairs, we will have 1.3, 1.5, 1.7. So here we are adding 0.2 to get the next term. So the next two terms will be 1.9 and 2.1. So finally, we have our answers here. For part D, the first term will be 1/10, 1/5, 3/10. So this is in fact 2/10. It is equal to 2/10. So 1/10, 2/10, 3/10. The next two terms will be 4/10 and 5/10. But 4/10 is also 2/5 and 5/10 is also equal to half, because we are adding 1/10 to get the next term. Now, if we consider the second term of a sequence of ordered pairs, we will have -5, -10, -15. So here we have to subtract 5 to get the next term. Therefore, the next two terms will be -20 and -25. So here are the next two terms of a given sequence. 2/5, -20, and then half, -25. Now we will look at how to find the relation between ordered pairs of a sequence. As I had mentioned earlier, we can compare an ordered pair of sequences to coordinates. So if we consider the example taken before, this will be your X and your Y values. We have an example here. In each of the sequence of ordered pairs below, find Y in terms of X. Let us look at the first one. 1, 1, 2, 2, 3, 3. I will represent this information in a table. So the X values are 1, 2, 3. The Y values are also 1, 2, 3. So what can you notice about X and Y values? They are equal. So we say that Y equal to X. The second part, 1, 0, 2, 1, 3, 2. Again, I will represent the X and Y values in a table. So X has values 1, 2, 3. Y has values 0, 1, 2. Can you try to see what is happening between the X and Y values in each case? Here I have 1, 0, 2, 1, 3, 2. Yes, we are subtracting 1. So we say that Y is equal to X minus 1. We take the X value, 1 minus 1, we get 0. 2 minus 1, we get 1. So Y will be equal to X minus 1. Let's see. 1, 3, 2, 6, 3, 9. Again, I have my table. X values 1, 2, 3. Y values 3, 6, and 9. So try to find the relation which exists between these two, X and Y. Yes, we are multiplying by 3 to get the Y value from the X value. So Y will be equal to X times 3, or simply Y equal to 3X. Part D, 2, negative 2, 3, negative 3, 4, negative 4. So again, we have our table of values. Can you find out what is happening between X and Y values? Yes, we are multiplying by negative 1. So we will have Y equal to X times negative 1, or Y equal to minus X. So now you have some questions to practice on what we have just learned. The first question, find the next 3 terms in each of the following sequences. Number 2, find the missing terms in each of the following sequences. And number 3, find Y in terms of X for each of the following ordered pairs of sequences. So you need to find Y in terms of X. You also have some interesting links for you to get additional practice on what we have just seen together. So students, in today's lesson, we have learned about the Fibonacci sequence, which is a sequence of numbers in which each successive term is obtained by adding the 2 previous terms in the sequence. An example will be 1, 1, 2, 3, 5, and so on. We have also learned about sequence of ordered pairs, and we have Seeing that, we need to consider the sequence of ordered pairs as two separate sequences of numbers. That is, the first set of numbers will be the x values, and the second set of numbers will be the y values. And then we have learned how to find the relation between ordered pairs of a sequence. We have also learned that we need to consider these as x and y values. We compare these to coordinates. So in this case, we will have x equal to 2 and y equal to 6. And here you can see that we need to multiply by 3. So here we will have y equal to 3x. So students, we have reached the end of the second video on sequences. I hope you have understood the two types of sequences. So until we meet again in the third video, it's goodbye from me. Thank you for your attention.